So, how's the weather? Yeah, that's pretty much like the most boring question ever. But that's rather apt, because see, if it weren't for us humans burning fossil fuels left and right, this would actually be an incredibly boring period of time for our planet. See, Earth has seen some crazy stuff. Like there was this one time when all of Siberia got covered up in megavolcanoes and plunged our planet into a nuclear winter. And then India went and did the exact same thing just a few million years later. Or there was this other time when so much carbon was released from frozen methane deep down in the ocean, and it evaded up into the atmosphere, that it filled our atmosphere with so much carbon that it's on par with taking all of Monterey Bay, filling it with gasoline, and then lighting the whole thing on fire. Yeah, Earth has seen some crazy stuff. But the big question here is, how do you all know I didn't just make that up? First of all, I didn't. But also, if you are so inclined, you can read all about it and more in Earth's underwater libraries. Okay, these are called sediment cores. Okay, the youngest sediment is at the top, the oldest sediment is at the bottom. And written down, you can read all about Earth's climatic and geologic history. There's one caveat, though. It's not written in English. It's not written in Spanish. No, it's not written in any language that we generally speak on the day-to-day. No. Instead, it's written with chemistry, specifically the chemistry of salts. And no, I'm not talking about sodium, that common table salt. No, I'm talking those rare salts like lithium, magnesium, calcium, strontium, and barium. These 5 salts do an excellent job of tracing Earth's climatic and geologic past. But the thing is that we need to understand, in order to read this written down record, we need to know how and why they end up in the ocean in the first place. This is where my thesis research comes in here at UC Santa Cruz, because I study these 5 salts and 2 of the most crucial inputs that make your ocean salty in the first place. Specifically, rivers and groundwater. Rivers, we all know about those, right? You jump in them, you raft in them, they all eventually lead out to the ocean. Groundwater, it's a tad more cryptic. We know that we pump it out of the ground to drink, but after that, it actually does in fact flow through the sediment and leaks out into the ocean. Both of these conduits bring with it the salts of the land and translate what's happening on the land, in our climate, out there into the ocean, so that it's recorded for us to read about. So, in a nutshell, I study the chemistry of rivers and groundwater now, so we can better reconstruct Earth's climate in the past and improve our forecasts for Earth's climate into the future. Thank you.